All right, we're just going to do a few problems from the work practice problems dealing with work. We're going to start out with the definition of work. What's the definition of work in physics? It is force. Let's see, force applied over a distance. Okay, so force applied over a distance. That's what work is. How is work calculated? Work equals force. I'm going to put the dot that stands for times, distance. So work equals force times distance. Okay, you're also going to notice that we have our triangle here, our formula triangle. It's on each page. So I'm going to do a few of these, and then you're going to do at least like 6 or 7 on your own. So just pay attention to how I'm doing it, and the rest of them should be easy. If you have any questions, let me know. Okay, so Maria, number 1, Maria is pulling a full cart of groceries across a parking lot, or pushing a full cart of groceries across a parking lot. She applies a force of 50 newtons, and the cart moves a distance of 20 meters. How much work did Maria do on the cart? Okay, so the question is, we want to find work. Okay, so I've underlined the numbers. Let's see what those numbers mean, especially when we look at our force triangle. So 50 newtons, that's going to be force, 50. So we've got force equals 50. Put in the newtons. And then we've also got this 20 meters. That's going to be distance. So we've also got the distance equals 20. Okay, and what we're looking for is work. So I'm just going to put a question mark because that's what we're trying to find. Okay, so the equation to find work is, if we just go to our little triangle, we would cover up work. Okay, that would leave us with F and D. Okay, and when we're going across, we got to multiply. So in other words, the formula is going to be work equals F times D. And we have 50 for our F. I'm going to multiply that by D, 20. Ends up equaling 1,000 joules. All right, number 2, Ahmed is lifting a 10 kilogram box onto a shelf that is 2 meters high. How much work did Ahmed do on the box? Okay, so we got a 10 kilogram box, 2 meters high, and work is the question. Okay, so this is a little different. We got a mass and we've got a distance. Okay, but here's the thing is, the equation is going to be work equals force times distance. Okay, we don't have a force yet. Okay, we've got a mass and a distance. So here's what I'm going to do is we're going to start off, we're just going to go, okay, like we need force times distance, but we're going to start off with, we have a force that we don't know yet. We have a D that equals 2 meters. And then we have work, which is what we're trying to find. Okay. Here's the thing is that even though they don't say it, the enough information is in there. So first we got to find force. Okay. So we're going to go ahead and try to figure out what the force is from the information they give us. All right. So if we think back to, force equals mass times acceleration. So we've got, let's just figure out F first. Force equals mass times acceleration. Okay, so in other words, we've got a mass of 10. Okay, and we have the acceleration is going to be gravity. Okay, so because he's lifting and he's overcoming gravity by lifting it up. So we're going to do 9.8, that's our acceleration for gravity. So now we have mass times acceleration. That's meters per second squared. Okay, so 9.8, and we end up with 98. Okay, so that's our force. Okay, 98 newtons. Now we can go back and put in the 98 newtons. Great. Now we have force and distance, so we're just going to go ahead and work those out. So 98 newtons times 2 meters. And that's going to give us our answer. It's going to be 196 joules. All right, next one. Juan is pulling a sled across the snow. He applies a force of 80 newtons to the sled and moves a distance of 30 meters. How much work did Juan do on the sled? Okay, I'm going to go through and underline my numbers again. 80 newtons, 30 meters. Okay, so we have a force and we have a distance. Great. So we're going to go ahead and write down the force is 80. The distance is 30. And we want to know what work is. So that's the question mark. Okay, so we're going to go ahead and say, work equals force times distance. Okay, and in this case we have both of them, so we're just going to say 80 newtons times 30 meters. Okay, and that's going to equal, if you use your calculator, might be a good idea to be using your calculator this whole time, following along. 80 times 30 equals 2,400 joules. Okay. All right, so we're going to skip down to some harder ones, or just ones that are different. Everything else is trying to get you to find work, okay? You know what, we'll go ahead and do one more that has to do with kilograms. Okay, we'll come back to number 4, okay? So Fatima has a 20 kilogram backpack, goes up a flight of stairs 10 meters high. How much work did Fatima do on the backpack? Okay, so do we have F? We actually don't know F yet. So we've got a mass and we have a distance. We do have a D, 10. And then work is what we're trying to find, because it says how much work, right? Okay, so go ahead and looking at what we got. We have a mass, and then again, we are fighting against gravity. So we have our G, which is our acceleration in this case, 9.8. Okay, so I'm gonna go ahead and just figure out the force first. So we have F equals ma. Okay, in other words, we have mass 20 kilograms times 9.8 equals, let's see. All right, that's going to be 196. Newtons. Okay, so that's going to be 196. So now we have our force is 196 newtons. Okay, so we figured out the force first with the information we have. Now we're just going to go ahead and solve it for work. Force equals F times D, or sorry, work equals F times D. And so now we have the force, 196, and times 10 meters. Okay, is going to equal 1,960 joules. There we go. Okay, we're going to go down to one of the more difficult ones. Or one of the ones that's just different. Let's go ahead and look at number 10. Okay, so Raj is lifting a dumbbell from the ground to a height of 0.5 meters. He does 50 joules of work. How much work? Oh, you know what? This is supposed to be force. It'll be force on your thing. So how much force did the dumbbell weigh in newtons? Okay, so in other words, let's see, force, let's go ahead and write down our force, distance, and work, okay? So we've got our distance is gonna be 0.5 meters, even though it's a height. Then we're also gonna have our work. We actually have, so we have 0.5, then we actually have our work, it's gonna be 50 joules, okay? But we're trying to find what's the force, okay? So in this case, since we know the work, we're just gonna cover up work. Go back to our triangle up here, cover up work, and that leaves us with F times D. Okay, so in other words, the formula to find work, or the formula to find force, F equals, whoops, I'm sorry, we're supposed to cover up force. Okay, force equals W divided by D. Okay, so force equals W divided by D. In this case, we have both. We have 50 joules divided by 0.5 meters. Okay, and that's going to equal 100 newtons. Okay. So in other words, it weighs about 100 newtons is the weight of one of those dumbbells. Okay. So that was an example of how we have to go back and look at which one we have to cover, what we're trying to find. So we were trying to find force, so I have to cover F. Okay, I accidentally covered W at first. People make mistakes. Okay, so covering F, you see that we have W divided by D, because going down, we have to divide. All right, and then that's how we got that. Okay, all these other ones, 11, 12, 13, are going to require you to come back to the force triangle. Okay, so use that. It's on your paper. It's on the page. Let me know if you have any questions, and go ahead and do all the ones that we haven't done yet.